Okay. Hello everyone. I'm Zhuoxing from Tongji University, and this is my topic. This is my presentation for the casual 2020. My topic is about how to construct the digital multiple agent system to analyze, optimize the public space, and I also taking the public space of the northbound Shanghai as an example to you. And this later is my presentation. Thank you all. And here is my theoretical map. And I constructed the theoretic about the behavior research in the public space from the behavior research area and the waterfront public space area and multiple agent systems space area, and construct my topic and choose 837 articles to build this map. We can see this theoretical map here, and then we can see this became a hot topic now, and more and more people talk about behavior in the public space and utilize the digital method. And the tendency here is not only utilize the digital method to do the land use and city planning or computer simulation, but now more and more people care more about how to show the social relationship more precisely, and to construct the different model to show the relationship between the different factors in the public space or in the city plan, but not just in the form, in the shape. And from the research background, this concept comes earlier from the complexity research, the complexity science. And people also built the self-organizing city perspective, and to see how the city work as a people, work as a whole. And here the city can grow, and the space also can grow by itself, and there are dynamic city and dynamic factors in the space to define what the space is. And so people invite different methods to research it. The simulation is a very important method. Also, the multiple agent system can be utilized to research this topic. And my main method is a multiple agent system now. And how to construct a multiple agent system, you need to construct the agent and research how they interact with each other here. And you need to also research what you need to research in the environment, and build how your and find out how your agent will interactive with the environment. And the multiple agent system can also work with different algorithms like the Freudian force or biological behaviors, and so the multiple agent system can do a very good model for the self-organization problem in the safe space. And here is the basic structure about the circular automation and the multiple agent system. And so the most important in the multiple agent system utilization is how you simulate your behavior and how you construct your environment. And in our example, we take the waterfront in the Huangpu River as an example, and especially take the Hongkou northbound of the waterfront public space as our example. And here is also different infrastructures and facility has all have been built here, and they are in very good materials and good shape. But what's the problem with them in the reality? We need to find out that. And so we mapped the different infrastructures and facility here, the greens, the bus stations, and the people walk paths, and the different boundaries for the elements in this map. And also we need to find out what is the things interacting with the real environment is the people, and the people the sort of the people. So we need to collect the basic information from the peoples, and also their use preference for the peoples. For example, what is your most preference in this area? Some people will choose the sport facilities, but some people choose the shop. And according to our research, we classify our research groups into 3 types of groups and build 3 classification templates. It's the elderly, family, and the adults, and they have different preferences for that site. And also they have different methods to get here, by the subway, bus, or walking directly to their destination. And in the program, we built their different behavior according to that 3 types of groups, and with different force. For example, view force, content force, wander force, separation force in the agents. So the agent can represent the different types of the group. And then we also built our environment into a vinyl, into a computer, and the boundary here according to our research map. And then we can do our simulation. The particles represented elderly, they can initial from their bus station or some entrance from this map, and so they search for their needs and go for their destination. They have different destination and behavior in this map, and finally there is can emerge activity pattern like this. And also this is the activity pattern of the adults, and this is the activity pattern of the families, and we can overlay the 3 groups of them, the patterns in just one pictures, and so we can almost acquire the activity happens, how the activity will behavior in just one map. But we also need to compare our simulation result with the real situation. So we compare them with some real people or work trace here, and to know if our model, our simulation is correct. And based on our simulation, we work out some suggestions for the design. For example, we will connect some area, make this area can be reached directly, and we also add some entertainment facilities, and we also add some green area. And we also do the simulation with our design, and this is before our design, this is after our design with the 3 groups of the particles. Here is the simulation with the elderly particle groups, simulation with the family particle groups, and here is the comparison result. The left one is the simulation before our design, and the later one is the simulation after our design. We can see some area, the people behaviors, and people crowded more before that, and some place which we think they are very crowded before. Now they can have a more relevant, more comfortable people here. That is how we utilize with the multiple system to support our city regeneration. And our research has 3 types of characteristics. The first one, we built a visualization method between the behaviors and the space. And our research is a dynamic process, so it can predict, and it can analysis to support whether your design or the space regeneration is good or not. And also our system is a free system. A multi-edge system is free system. You can construct it, depends on your research, and you can customize your own research object group. But there are also some limitations here. Our classification just classify the objects into 3 types of group. That may be eliminated, and we don't think about the more about the vertical connection in this map. Some stairs, something like that, because people won't behave the same in the horizontal space and also in the vertical space. That is our limitation also. And in our whole research here, we just have a single process activity simulation. The particles emit from their starter and walking in the space and finally disappeared in their destination. But they haven't have free behaviors here. And in next stage, how to build the free and more diversity behavior in the particles is our technical difficulties. Here is my report here, presentation here. Very thanks to all of you to listen to my work, and here are also so many things need to be improved, and hope I can got more good suggestions from you, and very welcome you all to send me message. Thank you very much.